Hello and welcome to Example 5.5. We're going to look at personnel testing at ZTEL. So the personnel department at ZTEL has a large communications company, is reconsidering its hiring policy. Each applicant for the job must take a standard exam, and the no hire decisions depend at least in part on the results of the exam. And in the next tab, we have a sample historical scores, and they're approximately normally distributed. The current hiring process occurs in two phases. The first phase separates the applicants into three categories: automatic accept, automatic reject, and maybes. Automatic accepts are those who score 600 and above. Automatic rejects are those that are 425 or below. And then all the maybes go to a second phase where some other factors come into play. So what we want to do is we're going to use a histogram and see, is the historical data normally distributed? Then we're going to find what's the standard deviation and mean of this historical data. Now the question will be, what percent of future applicants will automatically be accepts and rejects based on this historical data? And the last is, how would we change the policy to automatically reject 10% of the applicants and automatically accept 15%? So the very first thing we want to do is, let's go to our data here and let's make a histogram. And this is important for us because this will help us figure out if we have a normal distribution. And so we'll go histogram. And so let's just Control X to cut it. I come all the way back up to the top here. Control V to paste. And there is our histogram. Once again, axis titles. And these are scores down here. There's no units that I know of for that. And along the side we have frequency. And this would be the distribution of test scores. Always important to label these things as soon as you make them. So the question is this a normal distribution? Well, approximately, yeah, it is. It's bell-shaped, and it's got a peak in the middle. It comes down, and it appears to follow that normal distribution. Is it a perfect one? No, because, I mean, this is a little bit higher here, a little bit lower, but we can approximate this as a normal distribution without too much of a problem. Okay, and so now we need a mean and standard deviation. Excel makes it really easy. We'll do average of all of the test scores. And hit enter. Gives us an average test score of 525. And then I'm just going to Control C, Control V. Now, I did the Control C, Control V within the context of highlighting the equation. If I would have just done Control C and Control V and dropped it down, what happens is when you do that kind of paste, it automatically indexes and moves the cells around. And so what I was doing is I just wanted to grab the exact same equation, so I just highlighted it and Control C. The reason I wanted to do that is I was just going to come here and go stdev.s for the sample, and then change that to find my standard deviation. Great. So there's our first part of the equation. Next, what percentage of future applicants will be automatic accepts and rejects? Well, we're going to do that all based on a normal distribution using, so this would be a non-standard normal using these two numbers. So what I want to do is actually, we're going to bring these over, hit equal, draw that over, and do the same thing. In fact, since that one's right below it, I can just grab it, drag it. And so that way, if anything changes, that'll update, and I'm all fine with everything. Okay, so as of right now, the automatic accept point is 600. So if we think about it, in the future then, what is that going to be? Well, we have a normal distribution. That's what we're saying that we've approximated everything by. So what I need to know is I need to know what is going to be greater than 600. What's the percentage chance it'll be greater than 600? Now recall, we can sit there and go normal distribution without the S because it's not a standardized one. And then I can go, well, what X value am I looking for? Well, that X value is going to be our automatic accept point. And now what am I looking for? Well, the next part is the mean, which we've calculated here, F4 to lock it in. Our standard deviation, F4 to lock it in. And we're going to do true because we want a cumulative. Now, once again, if we do it that way, that tells us that at 600, the chance to be at 600 or below is 91.4%. We want to know what's going to be higher than that. And to get higher than that, we have to take 100%, subtract from that the chance that it's going to be less than that. And that tells us that via our current policy and are based on our historical data, we estimate that 8.6% of future applicants is going to be automatically accepted. How do we do rejected? Well, rejected is going to be just our normal distribution. Control C. Once again, I'm kind of cheating here. Well, it's not really cheating, making less work for myself. And instead of, we're going to go B8, which is our reject point. So the normal distribution of B8 with a mean and standard deviation given. So the chance that we're going to reject someone is going to be 3.43% based on historical data. So from our historical data, those are the chances that we're going to have things going, and we can make those assumptions because we have assumed that we're going to be operating, that our historical data is a normal distribution. Okay, so now we're going to go to the accept point. So remember, norm.dis is going to give us the percentage chance that we're going to be at certain things. And what we're going to do down here is we're going to go to norm.inv. And if it was norm.s.inv, it would give us the z value, the standardized value. But in this case, we're going to use norm.inv, and it's actually going to give us that value of where that 15% chance is. So the first thing we'll start with is equals norm.inv, the inverse of the normal distribution calculation, the probability we want to know. Now, if I did just 15% and then said that there's my mean, F4, comma, my standard deviation, F4, comma, and we're going to make that true or 1. Oh, actually, no, just don't need that for there. If I go and do that, that tells me the automatic accept point would be 468. But remember, that is going to put us at, that's 15%. So that's working from this way. That's going to be the bottom 15%. We want the top 15%. So 1 minus, so 100 minus 15%. So that tells us to get that top 15%, that's going to be the 85th percentile. So that is going to be 582. Okay, and so now we're going to look at the automatic reject point, and this is, since the automatic reject point is going to be 10%, we don't have to do any of this minus because we want the bottom. This was asking for the top 15%. We're going to be looking at the bottom 10%. So once again, we go to our norm.inv equation. Our probability is going to be 10%. Our mean is going to be that. Our standard deviation is going to be that. We're going to close that up. And so that tells us that if we set our automatic reject point to 486, 10% of all the applicants should be filtered out based on our historical data. If we set, so we're going to up our automatic reject point a little bit. We'll go from 3.4% rejection to 10. If we drop our automatic accept point from 600 to 582, we should go from an 8.6 automatic acceptance rate to a 15% automatic acceptance rate. And that is how we would use historical data fitted to a normal distribution to calculate out percentage chances things are going to happen.